Hi, we're Group 24, and our project is a multi-purpose exploitable server, a server that has the ability to selectively enable insecure portions of code that can be exploited.
Hi, I'm Tim, and I'm the project coordinator.
I'm Tessa, and I'm the project researcher.
And I'm Alicia. I developed code and tests to ensure working software. Cybersecurity attacks have a potential to cause extensive damage to an organization. We created a server to detect and collect information of attempts from attackers to exploit vulnerabilities geared towards strengthening and protecting networks in the future.
Our project description has three parts to it. The first is creating honeypot software that can selectively emulate common vulnerabilities. Over the course of the semester, we've implemented a cross-site scripting vulnerability, a command injection vulnerability, as well as a few others. Some of these vulnerabilities can be enabled when starting the web server. The second is the ability for our server to collect and record logs about what is happening in the system that will hopefully give an insight into attackers' methods. We use the Python logging module in order to log events in our server. The third is the ability to use the software for pen testing, giving an accessible way for cybersecurity beginners to gain knowledge of common attack methods. People who are new to cybersecurity or still learning can test the server for vulnerabilities, ultimately increasing their knowledge of some common exploits. Our server went through three stages of development. First, we completed the basics of our project. This included coding a working web server with web pages, server logs, and alerts, as well as a graphical user interface for starting our server. We used the Python language to code our web server, GUI, and logs, and we used HTML, CSS, and some JavaScript to code our web pages. Second, we worked on the exploits for our server. We were able to complete a cross-site scripting vulnerability, a way to view correct answers to a quiz, a command injection vulnerability, and a denial of service attack. This step required a lot of research and testing. Lastly, where supported, we have created a makefile so that the server would be easy to get running on your operating system.
There were a few changes from our initial proposal. A check mark in the first column indicates the completion of one of our planned stages of the project, while a check mark in the second column indicates that something changed from our original plan. We were unable to complete stage 3, which consisted of additional features such as protocol types and vulnerabilities. There were also several changes in stages 2 and 4. In stage 2, the vulnerabilities we implemented were switched around with the ones mentioned in the previous slide. And for stage 4, we decided to go forward by making a makefile so that the project can easily be installed and run on several different systems. We learned quite a lot throughout this project. Some of the first issues we encountered were when we were beginning to build the web server. We were familiar with getters and setters in Java, but had to learn Python's equivalent, using decorators. When creating an insecure quiz, we also had to learn the easiest way to check for correct answers using JavaScript. Later on in the project, we needed to get more familiar with the details of GET requests and POST requests in order to develop the server code to handle these requests. Finally, we also learned about different exploits in order to implement them.
We have a working server with web pages and logs that can be used on 3 different platforms: Linux, Windows, and Mac. Our web server has 4 known vulnerabilities working, including a way to view the correct answers to a quiz, a cross-site scripting vulnerability, and a command injection vulnerability, as well as a denial of service attack.
Here's the UML diagram of the codebase. It's pretty dense, so I'll give a brief overview by dividing it into 3 parts. Within the first yellow rectangle is the start code and configuration code when the server starts up. Within the second rectangle, that's the code that deals with the socket handling and protocol types that the server supports. And within the last rectangle, the honey-colored one, are the modules that can be swapped in or out in order to determine which vulnerabilities are present at the start time of the server. Here is a brief demonstration showing the basics of the multi-purpose exploitable server project. It is started from the shell, and if no arguments are provided, a simple graphical user interface will launch so the server configuration can be set up. Once it's started, you can then navigate to the default web page via a web browser. Okay, after typing in the IP address or URL, you will then be able to see the request logs in the shell window. Here it is. Thank you.
Here's a brief demonstration of the cross-site scripting vulnerability available in our server. Users are able to navigate to the discussion page where there is a section for comments. When a user inserts malicious code, for example, an alert box, into the submission section, the input is then saved into an HTML file on our server. Once the page is accessed, the malicious code is run and displayed on the screen if applicable.
This is a brief demonstration showing the visible quiz answers vulnerability on our web server. From the main page, we navigate to the quiz. Once here, we can right-click and select Inspect. To find the answers to the quiz, we expand Form and then Script. In addition, here is a quick demo of command injection. From the main page, we navigate to the discussion page, and in the comments box, we add a command. Since we are running Windows, we will try echo. Once we hit submit and refresh, we will see the command working in our terminal.
There are numerous things that we could do to further expand the capabilities of this project, and it comes into three major categories. First of all, there's additional protocols, such as HTTP3 or SSH. Next, additional vulnerabilities. We could implement buffer overflow, SQL injection, and more. And finally, expanded capabilities, such as packet capture or having the server masquerade as other technologies to better lure in potential intruders.
Thank you for attending our presentation. Special thanks to Dr. Brewer, who provided his time and expertise throughout the semester. Are there any questions?